Okay, hi. Who is a game dev or want to be a game dev here? Okay, that's fine. So, I'll talk about Haxe. Haxe has been in the vicinity for like 10 years. It's slowly gaining traction and now has roughly the same GitHub projects as TypeScript or stuff like that. So slowly becoming mainstream. And I'll explain why is Haxe interesting as a game dev and why it was made by game dev for game devs, and I will explain some features that make it unique and pretty much useful. So who am I? I'm David Blackmagic. I'm now at a company called Bank Lab. I was at Motion Twin, a big free-to-play company, and I was before at Monkey. I make games since year 2K. I'm a one-man army, as we call them. I've recently made Double Kick Heroes, which was ranked 15th overall in the Doom Day and stuff like that, and it really made a little buzz and it was fun to do. And I've made some 20 plus commercial games on consoles and stuff like that, with low levels, and won 2 Game of the Year, one for Advanced DSI and one for Mush, which is a deception online game, which was a little success. I'm also an activist. I do a lot of hacks. I don't code the Haxe compiler itself, but I take care of optimizations and testing and stuff like that. So, okay, I really try to fit in 25 minutes, but I'm already late, so let's get on. Since it was an open game dev room, I feel obliged to talk a little bit about open game and open source games. Since I come from a commercial background, but I often open source my games, there is still some things to say, and I don't know if people spoke about that, but I'll throw my little stone. Then I speak of Haxe and when can Haxe help, and if we have a little time for QAs. Okay, indie and game dev has been a heartbreaking challenge. Many open source games are game jam entries. There are many successful open source games, but many are a bit limited in terms of scope. You know, for example, Frozen Bubble is a ripoff of Bubble and stuff like that. And for us commercial makers, it's a bit of a problem because we feel we are not that much welcome in this environment. I'll speak about the emergence of new markets in the Linux desktop. Of course, open source game is just not Linux, but it's still a market that has great possibilities. So for us, a free-to-play company, for example, the lowest income per user were from Linux users, who we took care to have a bit of a nice Linux version of the games. It was in Flash at the time, and we had a big Linux vocal community, but all in all it was for games 1 to 4% of users, and they were the lowest paying users. Now there have been some progress since Steam get on Linux desktop, and we've seen very much progresses in terms of numbers. But for Steam, Linux users are still 1 to 3% users. Some different sources, but it's around 1, sometimes 3. There are some successful titles. Steam reports actually the income per user for Linux users is comparable as Mac, which is far higher than Windows users. So I think there is a place for Linux desktop to have really games with a true market. I think there are mentality to change and some things to evolve, but it's really encouraging. Or Android has become hostile to us indie game developers because the market is so bloated with everything and nothing, and the discoverability is so low you can just make something. Today, if you want to make a good Android game, you have to pay for acquisition and stuff like that, and it's not really welcoming for people who try to have an indie focus. So, I just took a very simple sample. I found tens, but I think this one is cool. It's just, I googled Fedora games, and the page says, the page should be revised or reconstructed. This page needs some love, because there was a whole page which was boring, etc., etc. So yes, games should be welcomed and cared, or you can contact men from the game development companies, etc. We will be happy to sell our games, I mean, but we really need some love. The Ubuntu app directory was just a tiny bit better because it authorized commercial games, but the games are not open source. We don't know the numbers of the games. We don't know the business volumes of money. We don't know. There is no labeling. There is no discoverability. It was disheartening for us. So usually we put open source games or prototypes or Ludum Dare or stuff like that. But it's really hard for us to say, okay, let's try something and make a full game fully open source with the community, release it on Steam, etc. I don't know many examples, and I'm yet to learn. So there is a true emergent gaming culture in Linux desktop world. It needs chicken and eggs. Of course, there will be people who will take the risk to put their code base, take the risk to have hackers hacking the web server for the leaderboards, rip the data, etc. But we need help if we want to achieve this. We need welcoming from the platform. There are more and more platforms very interesting, like itch.io. We need funding. I think distros and people which are making big money should fund indeed game developers. If they come to me and say, okay, we pay you for the year and you release all your game, all open source, I will be happy to do that. So maybe we should start discussing with them, but generally it ends up with, oh, I'm only doing OS things, like games is just games, etc. So that's a debate we had with Richard Stallman like 12 years ago, and it's still at the same point. Creating, don't encourage clones, yeah, but distribution, the App Center needs to be buffed a lot. I mean, a real lot, because, for example, the Ubuntu app directory is cool for apps, but for games, it's just not reflecting the diversity of the themes or the gaming skills or anything that are related to game. It's an app directory. We should have something a bit buffed. So, what is Haxe? Sorry for the rant, etc., but I think it was useful to give my point of view since I do commercial. Haxe is not exactly only the German Rust, it's an open source compiler, it's MIT and LGPL. It's now around for 10 years. There is a compiler toolchain available nearly everywhere, and FreeBSD is on the way. It's a blend of Java, ML, ECMA. We are structured under Haxe Foundation. We are currently in difficulties of evolving, etc., because it's now getting traction with big actors. So we are upgrading our decision process, and we are actively seeking and researching and recruiting a CEO and a decision committee. So if you think you have a point of view, you can join us. So what is Haxe in essence? It's a transpiler, your code. The extension is HX code, and translate it in a target. It's not a VM or a collection of VM. It's real codes. It's native apps with native calls. I'll show you some code later. Basically, we have many targets: AS3, JS, Java, C#, Nico, CPP, Python, PHP, and I forget 2 or 3. We target many OS, many environments, many runtimes. So basically, Haxe is about bringing back the power to the game dev and say, you make a good game with good features, and we take care of the porting. We take care of what the pain in the ass is starting that fucking main loop. Main loop is everything for game developers and game engines, especially on all the systems. For example, on a PS2, it takes 2 calloc of lines to start that main loop. So that's what we do. Okay, now Haxe Classics. Haxe is a fairly high-level language. It has classes with inheritance, type inferences, which is a bit clever since it can infer arrays. It's a bit ECMA style. It has the good old for loops and functions, just like JavaScript. It's 21st century. There are true lambdas and not delegates or stuff of displays. Interfaces, built-in serializer, JSON, map, XML, all this kind of stuff you can find everywhere. There's something more dedicated to Game Maker. It's inlining. Since when you are a game developer, you really tackle the real-time side of things, you can't rely on a VM or a GIT to inline correctly your code, and most of the time you really need the true inlining by hand. So here I inline the alert function, and a compiler I've made tests on Java or CLR will never inline as good as you. It can produce better code on some sections, but on inlining generally you can do much better. But if you believe so, if you really believe the compiler can do better than you, we have a static analyzer in addition. We can also do metaprogramming. So we can even do some things that are a little bit like C structs, that is to inline classes on the stack and on the registers. For example, we have this class which has 3 float variables. We tag the function new, which is the constructor, with inline, and then the vector in Haxe, if you generate, for example, the CPP, will automatically produce 3 variables, which will possibly be in registers, since, well, you know, in CPP it always goes to registers, and not on the heap, and it will go really faster. So you can write very, very efficient code, which will be auto-vectorized very easily with very high and complex computations. Usually you can do that with CPP and stuff like that, so it's really cool. And for us game developers, having control at the compile time over inlining and stuff like that really allows us to do process that would go 4 milliseconds and now jump to 0 milliseconds because it's only registers manipulation. You know, it's all about the memory. The memory is the weak point of our infrastructures. Okay, for more specifically for game devs, we have sophisticated enums like in ML. So you can say an enemy is a creep, and then you say another enemy is a sorcerer with a level and a magical school, and then you can basically have only one class for all the enemies of your game and switch just the little tiny bit of behavior which is adequate. It really prevents cache misses, because when you have inheritance you have a lot of cache misses and redirections, and it sucks. So you can really nest your behaviors with this kind of enum. They are well known, but I don't know if all languages have them now. We have also really native accesses, which means when you are in Haxe, you can really always, and we guarantee that, avoid the abstraction leak and go back to the memory or the core language, which means we have high-level bytes and byte views. We have many native libraries, and they are easy to buy. I will explain later. And we have a native cheating, which means Haxe really thought we will do our best, but when we unit control, you will have it. So we have a magic API which allows to write a pseudo code which is pseudo portable. For example, you can write the same pseudo code which will really call Java or C++ code with a string interpolator. Okay, more sugar. For prototyping, when you want to go fast, you know there are dynamic objects which are very cool in most Lua, GDScript, and stuff like that. We are typed in Haxe, which means we can go potentially faster. We don't need a JIT, and you can do type checking to ensure the game will not break when you change a gameplay element. We really think it's capital for a game to scale in the duration to have a good type system. And since we have type inference, the type is relatively soft with you, it won't bother you. But we still have it. And for prototyping, we have pseudo-typed dynamic objects. And we can also shortcut the types, which means you don't have this Java bloat feeling with com.toto.things, etc. You can just import a class with all your type defs, and then all your code can be in 3-4 word variables, etc. And you can really have a mean code. The language is basically garbage collected, but since we like game devs, we have set up most garbage collections at good levels. We have put in place the inline U and stuff like that, so you are really in control of the garbage collector. If you want to allocate zombies, which are objects which will survive the garbaging and stuff like that, you can. So in that respect, we are really focused on having the garbage collector under control. We have getters, setters, reflexivity, full dynamicity if you want. Abstract. Okay, I made a typo, sorry. For example, in Haxe, something useful is fixed 16 with the abstract keyword. If you know the PS3 and Xbox One and stuff like that, you know that the GPUs are basically working in fixed point notations. So it's really inconvenient because in C, on the CPU, you don't have fixed point, or you should do macros and complex classes or stuff like that to have efficient and readable ergonomic fixed point notations. With Haxe, you basically can declare an abstract which will be a type view over integer, and then add operator overloads to have your fixed 16 implementations. We also take care of the casting, just like ML. We forbid the casting between two non-compatible casts, but you can overload the casting. So, for example, if you want to cast your fixed 16 floating point value to strings, you can intercept every call, which is 5 minutes, okay. So it's really powerful because you can map your integer into fixed 16 and at runtime have no overhead. Okay, more on compile type abstractions, but I'll jump a bit. You also have a powerful macro system which allow you to inject Haxe functions in the compiler workflow. There are like 10 entry points, so you can manipulate the whole language itself. And for example, if you want to write a shader language or a gameplay cinematics language, you can do this in Haxe by Haxe and inject it in the compiler, and it will interpret the chunks you selected. You can also do that with external programs like OpenOffice or MySQL, and then put the gameplay in MySQL and suck it at compile time and inject it as typed objects. For example, if you have a warrior object and you make him lose his sword, your program will detect if there are no symbols defined as sword, it will not compile. It's very important for us game developers to do stuff like that, to iterate over our gameplay swiftly. Yeah, with Haxe macros you can do code injection, for example. Put XML chunks in the code and intercept the calls and retrieve them on the Haxe side and populate, for example, the on-click, on-button sequences, etc. So basically, in Haxe, you can do everything. If you want to change the whole compiler or the whole language, you can. There are batteries included. There are many bindings with HTML5, link, OpenAL, OG, etc., etc. Easy resource integration. Since we are game devs, we have put shortcuts everywhere to import, like PNG very easily, stuff like that. Bindings are easy to write. Binding SDL joystick is just these 5 lines. So when you are working on the CPP target, you can import your favorite library, do these 5 lines, and you have a high-level control over a C object, which is really powerful and allow you to make really cool things. We really worked about interoperability. We have big communities. Flexel, OpenFL, Stencil, Scratch are already full Haxe. There are editors, Vim, VS Code, debuggers. There are 2 kinds: Haxe Space, we have for CPP and Flash, and Target Space, the regular debuggers of the target. Like you want to debug your PHP Haxe code, you can with the regular PHP debugger. There is a try.haxe.org, which is powerful. So all in all, for us indie game dev, code ergonomy is a real challenge and is really important. The cognitive space is less bloated because you make more concise statements, you make more files, you pack more your data, more your objects, and it's really important for your game to be nested in your cognitive cache. Because when you overflow the cache, you will go less fast. That's why the compiler is very fast. To compile 10,000 lines of code, it takes 1 second max or 2. It's really, really fast, more retention, less boredom. For example, it's way faster than the Java compiler or C# compiler. We have live reload, advanced types, and the code generated is very readable. If I build and run, try the tax, the dog, I made a little function with the inlining. You can see the inlining took place and was working with strings. And the code generated is really what you type, what you would expect. And we have advanced dead code elimination pre-native compiler, which really helps to lessen the compile times on the native side when they are, for example, CPP. Last word, we have non-enemies. We have bindings over many engines like Unity, Unreal. I think there is a Godot binding also. We have Flash bindings, and there are many native Haxe kits which works above many targets. There is no kit which does all targets like Unity and Unreal and stuff like that. Usually they are a bit focused, but for the most well-known, Starling has a Haxe version, Blender has a Haxe exports, there is an engine called Car, Babylon, Apes, Flixout. All these have Haxe version or Haxe bindings. Use case. If I have a few more minutes. For example, if you want to use Haxe and Unity, you can use Haxe with macros to inject typed objects in your game so that it breaks if you do an error. And then use Unity regularly and you build your web services with Haxe. And since it's integrated with the same serializer, you don't have to duplicate code. You just code in Haxe and it's in Unity, and you don't mess up with servers and stuff like that. There is the same with Flash Mobile and mobile phone, etc. Haxe is my friend, why not yours? There are many things that can make you adopt Haxe. It's a great Haxe system, just like NPM. It can bridge gaps when there are hostile environments, meaning if you don't have OG support, you can port OG to Haxe, which was done, and then you have OG on 12 platform, even if you don't have C access. That's cool. It can help you write definitive code which you will just leave on the shelf and never see again, because basically when it's once in Haxe, it can cross years and platforms. It is maintained, shared, it powers billion-dollar companies like Disney and Nickelodeon. Their mobile apps are made with Haxe, with a toolkit which is named Flambé. And it also already powers famous indies like Terry Cavanagh, Lars Bousset, and Idori Eli. And that's it. That's it. Thank you.
For example, for performance reason, I need to export my code to CPP, C++. And
yeah.
Is there a possibility to have still a way to use Haxe as a scripting language?
Scripting, you said? As a scripted language?
As a scripting language to alter the game.
There is two possibilities. The guy behind XCPP made a CPP scripting target, which is hot reloadable and sending in files. So you can take the same Haxe CPP code, generate CPP IA for that, and send it over to your bundle to execute it, the same exact CPP code. And we also have an Haxe script target. You can write scripts and hot reload them, etc. So when you are on CPP, you have access to the full CPP code. Because Haxe generates CPP code, which is now accessible, you have access to the C runtime, and you can nest some things here and there, for example. Totally. Okay.
I had a question about the enums.
Enums.
Is it? You said it's quicker because it avoids going to cache misses. Is it because it stores? Does it store the complete, like the union of all those fields?
No, because most game developers, when they are young, make 10 classes for 10 enemies. I make only one classes for every enemies and just switch in the behavior component and then scan all behavior. So you really have a code space which fits the cache because we have few kilos of classes and not a large bunch of everything. And enums have several options, like you can do sophisticated enums, which nested the parents, and you can also fall back on abstract enums, which are virtual enums, which is mapping an enum to ints, or an enum to strings, for example, when you want to make manipulation. And that's the way we took strings from the databases, converted it to virtual enums, and then inject it in the code as typed. So if you compare your typed string with the enum that comes from the database and is broken, the compiler will say, oh no, it's not compatible, not in the same thing. So you can do very sophisticated gameplay iteration. Go on in Excel and just build a, oh, I made a mistake. That's very common.
Do you need to write anything for a particular platform, or is it just take care of, like, is all the rest of it cross-platform, or do you are you writing, like could you move, like, ship it to iPhone and then ship it to Android or something like that, or do you have to write some parts of it, you know?
Haxe functions at the language part. On top of that, there are frameworks which would take care of this. For example, for OpenFL, you can just with one CLI change do the Android platform, Raspberry platform, Windows platform, Mac platform, iOS, etc. etc. So really, it's the framework which take care of it. The code base will be the same. It's really this main loop, this bootstrap, which is usually a bit complicated and boring, especially on Android and stuff like that. So yeah, there are many frameworks which does that, but it's at framework level.
All right, well, thank you very much. Oh, very much.
About the build options,
The what? Excuse me?
build configuration, how do you set that?
The build configuration? Yeah. It's vast.
For example, in C++, you need to create files to explain dependencies.
I'll show you. Too bad I deleted this this slide. Usually, framework make a build tool because they always have to bundle resources outside the language scope, which is very limited. But Haxe in itself provides nice things. This is the command lines nested in a .html. Basically, you do Haxe myfile.html, and then you can have commands and parameters and stuff like that. And even in one file, build for 8 targets or stuff like that. So it's really streamlined in CLI parameters and stuff like that. There's also processor definitions like sharp if and stuff like that. So between the sharp if and the macros and the thing, you can really customize all the tiny bits of pain in the ass you can have in those kind of tool chains.
All right, thank you very much. That was great.